Hello people, welcome back, and we're going to continue with the AQA Spec 4.1 and Untitled Chapter 2. I'm going to talk about the periodic table and what you need to know in the periodic table as a whole. Okay, so let's jump into it.
It was a nightmare.
Activate.
Okay, so this is the part where we have the 4.1.2 periodic table section. So this covers this area over here of the AQA spec. Obviously, not all of this will come up, but there is some elements of it that will come out in the test. So you just need to have an overview of everything, and also because everything is related, you're always gonna need all that information. That's why you need to study all of it. Okay, so elements in the periodic table are arranged in order of atomic protons, the number and so of the elements with similar properties in columns and known as groups. This is called in the periodic table because the similarities. Okay, right. So what we got here essentially is they are telling us, or they are explaining us how to read the periodic table. Okay, they're telling us that the columns are called groups, and the elements in the groups are arranged depending on the number of electrons that they have in the outermost shell. You got group from 1 to 7, and the group 1 are the alkali, they all have 1 electron in the outermost shell, and then you have the group 7, which are the halogens, which have 7 electrons in the outermost shell. You also have the noble gases, which are group 8, or also known as group 0. And they are very unreactive because they have a complete outer shell, so they don't have to mingle with other elements in order to be stable. Okay, now when we're looking at this, it says explain how the position of the elements in the periodic table relates to the arrangement of the electrons and hence the atomic number. Yeah, we said that already. And predict possible reactions and probable reactivity in elements and position in the periodic table. So this is what we're talking about, that in group 1, as the elements go down the group, they become more reactive. And we said that because the outermost electron is further away from the center, which is positive, and because the amount of electrons they are in between them in the shells, as you go down the group, it gets further away from the nucleus, so it's very easy to lose those electrons. Okay, and that's what happens in group 1, the alkalis. Okay, now also in group 7 is the opposite. As you go up the group, the elements become more reactive because the atoms are smaller, so they're able to attract those electrons a lot easier. Okay, then we go into development of the periodic table. Okay, in here before the discovery of proton, neutrons, and electrons, scientists attempted to classify elements, arranging them in order of atomic weight, and that didn't quite work out because some elements will have higher atomic weight than others. A lot of the time you will have a question on how Dmitry Mendeleev's periodic table was successful, what makes it different from the other ones, and you want to say this. You basically want to say that he arranged them in order it says here, it's in some places changed the order based on the atomic weight, and the most important thing is that he left empty gaps for elements that had not been discovered yet. Okay, then we go into metals and non-metals. So elements that react in positive ions are the metals, and the elements that do not form positive ions are the non-metals. Okay, the majority of the elements are metal. Metals are found and left towards the bottom of the periodic table, and the non-metals found towards the right top of the periodic table. Okay, now this will ask you, students should be able to explain the differences between metals and non-metals, basic characteristics like physical and chemical properties. And this will be good for your next chapter, which is bonding and structure, because you need to understand this in order to go to that side. Okay, let's see if we can get a periodic table, and we're gonna talk about that in a second. Okay, so there we go. Group 0, elements in group 0 in the periodic table are called noble gases because they're very unreactive. Like we said before, they don't really react with anything. Okay, and if you think about it, helium, because it's a very small atom, it only has 1 shell and that's 2 electrons in its first shell, and because they're very close, it will attract them very strongly. It is one of the most unreactive elements. So they might just ask you about that. Okay, they might ask you yeah, I think there's not much about the group 0 that will come up. Okay, they might just ask you about why they're so unreactive. Okay, then we have the group 1. Group 1 are known as the alkali metals. characteristics: a single electron in the outer shell. The student will be able to describe the reaction of the first three metals with oxygen, chlorine, and water. Okay, in group 1 reactivity, these elements increase going down the group. Explain the properties of elements in group 1. Right, so this is basically touching up in what we said before. In group 1, as they go down the group, they become more reactive. We said that the atom gets bigger as you go down the group, and therefore the reactions are more vigorous and happen a lot more quicker. Okay, and we also you probably looked at the experiment with the alkali metals in water. Okay, where you put the alkali metal in the water, sodium will fizz about the top, and then you have lithium will fizz around the top, sodium will give a couple sparks, and potassium will actually burst into flames. Okay, you want to remember that they will give you a metal hydroxide and a hydrogen gas. Okay, so you have a metal plus water is going to give you an alkali metal plus the water is going to give you a metal hydroxide and hydrogen gas. Okay, and that's the gas that actually gets ignited. Okay, and we'll look at group 7, the halogens. Same thing as we said before. As you go up the group, they become more reactive, and they are more able to attract those electrons a lot faster, and they'll do displacement reactions. Okay, so if, for instance, chlorine has taken an electron, if you add fluorine to it, fluorine is more reactive, so it will displace the chlorine, and the same thing will happen in the alkali metals. If you have sodium chloride and you add potassium to it, you're gonna get potassium chloride, because potassium is more reactive. It's gonna displace the sodium and it's gonna take over the chlorine. Okay, and that's basically what you got here. Okay, remember that when you make salts, you normally will have a for instance, sodium chloride. The metal name goes first, and then the non-metal goes afterwards. You gotta also remember the only element. No, actually, is not for this. That's for more like Key Stage 3 question, right? Comparison elements with group 1. And for this, we're looking at, let me see, typical types of properties. Right, yeah, so this is some of the last things that we got to do. Comparison with the transition metals with similar properties which are different for the elements in group 1. Students be able to tell the difference, compare group 1 melting points, densities, strengths, and hardness. All right, so you got to remember some of the chemical and physical properties of group 1 of metals and non-metals. Some of the properties would be the metals conduct electricity, they're sonorous, they're malleable, you can bend them into shape. Some of them are magnetic as well. Group 1 will be positive 1, group 2 positive 2, group 3 positive 3, group 7 will be negative 1, group 6 will be negative 2, and group 5 will be negative 3. And that's all that you need to know, because it will be coming in when you look at structure and bonding in the next chapter. Okay. And then we have structure and bonding, and that we're gonna look at the next video. Okay, so if you do have any questions, please leave the comments and contact me, and I'll try to get back to you as soon as possible. Right, so that was part 2 with chapter 2 of Carbuto, when we talk about the periodic table and what you need to know for the actual test. So I hope you find that useful, and I'll see you in the next one. We'll be talking about structure and bonding, and that includes ionic bonding and covalent bonding. Okay, so that's it.